Hello and welcome to Teacher Ruhulah's channel. In this video, I'm going to work on exercise 3.2 of Cambridge Primary Mathematics Workbook 5. And this exercise is about square and triangular numbers. Square and triangular numbers. Square numbers are the numbers that make squares. And triangular numbers are the numbers that can make triangles. We will work on each of the question and show how they make triangles and how they make squares. We have some keywords over here, and the keywords are spatial pattern, square number, and triangular number. A spatial pattern are the patterns that include drawing. For example, if we have the pattern of the square numbers, so the square numbers can be 1, 4, 9, 16, and so on. If we use drawing to show this pattern, if we use drawing to show this sequence or this pattern, that's called a spatial pattern. How? For example, for 1, we use 1 square. For 4, we use 4 small squares. 4 small squares, which still give us a square. So this way of showing a pattern is called spatial pattern. And square numbers, as I said, are the numbers that make square. This is a square number. 4 is a square number. 9 is also a square number. Let me show this one by bits. 1, 2, 3. 1, 2, 3. 1, 2, 3. So this is now giving as a square. So this is a square number. 9 is a square number. On the other hand, square numbers are the numbers that we can get by multiplying a number by itself. How? 1 times 1 is 1 squared, and it's equal to 1. 2 times 2 is equal to 2 squared, and it's equal to 4. 3 times 3 is equal to 3 squared, and it's equal to 9. So 1, 4, and 9 are called square numbers because we got them by multiplying 3 with 3, 2 with 2, and 1 with 1. And the third keyword that we have is triangular numbers. Triangular numbers are the numbers that make triangle. How? 1 is a triangular number. So this can give us a triangle. We can use one triangle. Or we can use a bead to show that 1 makes a triangle if we make like this. 3 is a triangular number because 3 makes a triangle. 1, 2, 3. And now it's giving us an equilateral triangle. An equilateral triangle. 6 is a triangular number. How? Because it gives us a triangle. So 1, 2, 3, 4, 5, 6. This gives us an equilateral triangle. An equilateral triangle. So the numbers that can be arranged in a way that gives us a triangle is called triangular numbers. We have a worked example over here. This worked example says, look at these patterns made from squares. Made from squares. So it says the sequence starts at 1, 3, 6. 1 is 1 square, 3 we have 3 squares, and 6 we have 6 squares. If we check, they give us triangles. They give us triangle. And this one can also give us triangle. Now it says, draw the next term in the sequence. If this is 6, the next term for this is 10. How can we show? So we can draw one small square. We can show another 2 small squares, which is this one. And we can show another 3 squares, which is 6. And the last one that we can make is having 4 small squares. This is the next number, which is 10, and this is now giving us a triangle. So the answer is also provided over here, which is already drawn, which is a triangle now. And part B says, write the next 3 numbers in the sequence. The next 3 numbers in the sequence. So the first one is 1, then 3, then 6, then 10. Then we have 15. Then we have 21. Then we have 28, and so on, because it's asking only 3. So these 3 are the other triangular numbers that we have? Well, the answer is given over here also. They considered from 6 to the next 3 numbers that they have given is 10, 15, and 21. And 28 is an extra triangular number that I have given for you. Let's now scroll down to move to question 1. In question 1 of this exercise, it says, draw the next term in this sequence. Draw the next term in this sequence. So this sequence is the sequence of square numbers. This one is 1, this is 4, this is 9, and this one is 16. So the next square number is 25. We can draw the pattern 1, 2, 3, 4, 5. So this array over here is having 5 columns and 5 rows. So I have to draw another 4 rows over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And another one. 1, 2, 3, 4, 5. Now we have a 5 by 5 array, which makes a square. And we used 25 bits over here. Well, it says, what is the mathematical name for this number? The mathematical name for this number is square number. It is square number. So question 1 is solved. Let's move to question 2. In question 2, it says, draw the next term in this sequence. The sequence in question 1 was square numbers. But the sequence in question 2 is triangular numbers. So these are the numbers that make triangles, as I explained before. So the first one is 1, then 3, then 6, then 10. Let's see what other number after 10 is giving us a triangle. So let's continue writing it. Each row is 1 bit more than the previous one. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the next one is 15. It is 15. So we used 15 bits to make this triangle. This triangle, which is a triangular number. Now it says, what is the mathematical name for these numbers? The mathematical name for these numbers is triangular number. Triangular number or triangle numbers. Triangle numbers. I said that triangle numbers are called triangle numbers because when we arrange them as dot patterns. Well, question 2 is also solved. Let's now move to question 3. Let me scroll a bit down. Okay. Question 3 says, write the next 2 terms in these sequences. The first sequence, which is sequence A, is square numbers. And the second one is triangular numbers. So in part A, we have 1, 4, 9, 16, 25. So the next square number is 36. And after 36, we have 49. How are they formed? They are formed by multiplying a number by itself. For example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and 6 times 6 is 36. So 7 times 7 is 49. In part B, we have 1, 3, 6, 10. So the next one is 15. After 15, the next one is 21. These are the numbers that can make triangles, and they are called triangular numbers. Question 3 is also solved. Let's move to question 4. In question 4, it says, this pattern is made by adding 2 consecutive triangular numbers. So you know the triangular numbers from part B of question 3. We have 1, 3, 6, 10, 15, 21, and so on. The first one is 1. The second one is 1 plus the next triangle number. The next triangle number is 3. 1 plus 3 is 4. When we add 1 by 3, we get 4. So it gives us a square. And 3 plus the next triangle number is 9. 9 is also a square number. And 6 plus the next triangle number is giving us 16. And 16 is also a square number. Now part A says, look at the total in each term and complete this sentence. So we looked at the total in each term. The first one is 1, then 4, then 9, then 16. So the sentence says, the terms in this sequence are, these are the terms, 9, 4, 16. They are square numbers. They are square numbers. B says, let me scroll a bit down. B says, write the next calculation, complete with your answer. So 10 plus the next triangle number, 10 plus 15. 15 is the next triangle number, is equal to 25. Is equal to 25. So 25 is also a square number. Well, question 4 is also solved. In question 5, it says, find the value of 8 squared. 8 squared. 8 squared means 8 times 8. So 8 times 8 is 64, and 64 is a square number. So we either write 8 squared or 64. Both of them mean the same. Well, let's move to question 6. In question 6, we have some riddles. So it says, solve these number riddles. Part A says, this number is a square number, a multiple of 3, less than 25. Less than 25. Let me list the square numbers over here. We have 1, 4, 9, we have 16, 25, and so on. So because our number is less than 25, we don't have to include 25. 16 is not a multiple of 3, and that number is 9. It is a multiple of 3, it is less than 25, and it is a square number. It is a square number. So this one is 9. Part B says, the number is a square number, okay, an even number, a single digit number. It is a square number, it is an even number, and it is a single digit. It can be one of these 3 because they are single digit square numbers. So square number, 3 of them are square numbers, but even number, the one which is even is 4 over here. So this number is 4. In part C, it says the number is a square number, a 2-digit number. The sum of the digits is 13. The sum of the digits is 13. So these are single digit numbers. They cannot. 1 plus 6 is 7. 2 plus 5 is also 7. Cannot be. Let's see, 36, 49, 64, and so on. How about 49? 49, 4 plus 9 is 13. 6 plus 4 is 10. So the number is 49. This square number is 49, where the sum of its digits is giving us 13. Well, question 6 is also solved. Let's move to question 7. In question 7, it says, Zara has a lot of small squares, all equal in size. She uses the small squares to make a big square, or to make big squares. She can use 9 small squares to make a big square, which is shown here. We have one big square over here. Now it says, which of these numbers of squares could Zara use to make a big square? You know that the only numbers that can make squares are square numbers. So let's first find out the square numbers in this grid and write it down over here. 46 cannot be because it's not a square number, but 64 can make a square because 64 is a square number. And 14 is also not a square number. 4 is a square number. It can make a square. How? If you have 4 small squares, it gives us a big square. It gives us a big square. 24 is also not a square number, so I will cross this. And 100 is a square number. It is 10 by 10, so it makes a square. So I will write 100 here. 60 is not a square number, it cannot. 66 is also not a square number. This can also not make a big square. 18 is also not a square number. It's also not able to make a big square, but 81 can. It can make a square of 8 by 8 small squares. The same way, 9 can make, which is already made here. We have 9 small squares over here. And 90 is not a square number, so I will cross this one also. So the numbers that can make squares out of small squares are 64, 4, 100, 81, and 9. In part B of this question, it says, can Zara make a big square using 49 small squares? Explain how do you know? I can say, yes, she can. Yes, she can. How I know? Because 49 is 7 times 7, which is equal to 49. So we can make a square of 7 by 7 small squares. So this is the reason that we can say, yes, Zara can make. Well, we are done with question 7. Let me scroll down to move to question 8. In question 8, it says, write the missing numbers in the table. There is a tip over here. This tip says, remember that each row continues the pattern. Each row continues the pattern. So we will start from the left. We have 1 times 3 equals 3. Then the pattern continues. We have 1 here, it becomes 2, and 3 here, it becomes 4. 2 times 4 is 8. And again, both numbers increase by 1. In the third column, we have 3 and 5 because we have 2 and 4. So each one increased by 1. 3 times 5 is 15. And 4 times 6 is 24. 4 times 6 is 24. So the same way, we can increase this one by 1. This becomes 5, and this becomes 7. 5 times 7 is 35. In the next column, we have 1 more than the product. The product here is 3. 1 more than 3 is 4. The product here is 8, and 1 more than 8 is 9. The product here is 15, and 1 more than 15 is 16. The product here is 24, and 1 more than 24 is 25. The product here is 35, and 1 more than 35 is 36. It is 36. Now, on the third column, we have equivalent square number. Equivalent square number. So we have 4 is equal to 2 squared. 2 squared, as I said, means 2 times 2 can be written as 2 squared. In the same way, 3 times 3 can be written as 3 squared. So what number over here is squared that gives us 16? It is 4 squared equals 16. Here, 5 squared gives us 25. 6 squared gives us 36. So this one is also solved. All the missing parts are now completed or found out. Well, question 8 is done. Let's move to question 9. So I will scroll a bit down. Question 9 says, find 2 square numbers to make each of these calculations correct. We have to find 2 square numbers to give the given sum. So what 2 square numbers gives us 10? It is 9 plus 1 because 9 is a square number and 1 is also a square number. In part B, we have the sum of 20. So which 2 square numbers are they? It is 16 and 4. 16 is also a square number and 4 is also a square number. So it gives us 20. In part C, we have the sum of 40. Which 2 numbers can they be? It is 36 and 4 because 36 is a square number. In the same way, 4 is also a square number. So 36 plus 4 is 40. Part D is giving us the sum of 50. Which 2 square number can they be? It can be 49 and 1. 49 is a square number and 1 is also a square number. In part E, we have the sum of 80. Which 2 square numbers can give us 80? So we know the square numbers close to 80 is 81, which is more than 80, and we have 64 also. 64 plus 16 is giving us 80. 64 is a square number, and at the same time, 16 is also a square number. Which two square numbers gives us 90? It is 81 and 9. 81 plus 9 is 90. And the last one is giving us the sum of 100. Which two square numbers can they be? It can be 64. It can be 64 and 36. Because 64 plus 36 is 100 and both of them are square numbers. We are done with question 9. Let's now move to question 10. In question 10, it says, find the 10th term in this sequence. The 10th term in this sequence. We have the triangle numbers over here. We have 1, 3, 6, 10, and 15. To find the 10th term for this sequence, I give you a formula. This formula is n times n plus 1 divided by 2. N can be the number of terms that's given. For example, here it's asking for 10th term. For 10th term. So, for you to be sure if it is correct or not, I will try to find, for example, the third term first. So, to find the third term, we will write n is 3. So, we will write 3 times 3 plus 1 divided by 2. 3 times, we can continue, 3 times 4 divided by 2. 1 times 2 is 2, and 2 times 2 is 4. 2 times 3 is 6. See, the third term is 6, which we already have here. So in this case, we can use the formula and find out the 10th term of this sequence. Because this is triangle number, and to find the nth term of these triangle numbers, we can use this formula. So let's put the 10th term here. 10 times 10 plus 1 divided by 2. So we can simplify. 1 times 2 is 2, and 5 times 2 is 10. 10 plus 1 is 11. 11 plus 5 is 55. So the 10th term here is 55. If we continue, we can reach to 55, which can be the 10th term of the sequence. This is all about square numbers and triangle numbers. I hope it helps you learn how to find the problems related to square numbers and triangle numbers. And the follower who had requested, I hope it helps him also. If any of you want me to solve any question or any exercise of the books, please let me know in the comment section so that I should work and share it with you in the YouTube. Please make sure to subscribe to my channel. If you are new to my channel, like the videos and share the videos with your friends, your classmates, and also with your students if you're a teacher. Have a nice time and thank you so much.